So I gave you my notes on slope-intercept form. All of it should pretty much look like things that you've seen before. When I do rise or run, I don't care whether or not you go up or down or left and right. The left and right is determined by our slope tree here. Underneath that, we have the change in y over the change in x, which is basically what the slope formula finds, but I have an easier way to find slope, which I will show you in the next slide. If we go under y-intercept, it says when x is 0, then y is equal to, this is basically a coordinate point. If x is 0, then y is whatever. So if we're looking at this first equation here to graph, our y-intercept is 2, so our coordinate point would actually be 2 here. And you would graph that first point, which is right on the y-axis. Then you would go up 1, and I want a negative slope, which looks like that, so I'm going to go over 3 to the left. Or I can go down 1 and over 3 to the right. Regardless, either way, it gives me a negative slope. Then I just connect my dots here. Now the reason why I did my dots ahead of time was that doing it with the stylus does not make it look very nice. So go on to the next slide. So here I just want to show you how to find the slope-intercept form giving 2 points. So I like to find mine by doing a table. We have our x, we have our y, we know it's -4 and -3 and 1 and 2. This is the same thing that y2 minus y1 over x2 over x1 does. So we find -3, the difference between -3 and 2 is a +5. That's how many there's in between there. It's going up by 5 from -3 to 2. And on this side, from -4 to 1, it's also going up by 5. So when we're trying to find our slope, it's the change in y over the change in x. That's what those triangles mean, which is 5 over 5, or it's equal to 1. Now you could find out algebraically what y equals mx plus b, because we still don't know what the b is. And we know the m, and we have 2 x's and y's. I'm going to use the smaller one just because it makes it easier. So we're going to get 2 is equal to 1 times 1 plus b, which gives me 2 is equal to 1 plus b. If I subtract 1 from both sides, I get b is equal to 1. So my formula is going to be y is equal to x plus 1. Now I already did my 2 points and everything, but let's graph this like we don't know. So here we have our y-intercept of 1. That would be right there at the 1. And you would go up 1 over 1. It's positive slope, so you want it to look like this. And if we actually draw our line through the 2 or 3 points that we just have, there you have it graphed. Now, again, I'm showing you the graph. I already have points in there. I have easier way of finding the points that you put on a graph. But if you actually have to write out slope-intercept form, if we're going to do it algebraically, you want to get the x from one side to the other side by subtracting 2x from both sides. When we do that, the x cancels out. I get 3y is equal to -2x plus 6. I'm going to divide both sides by 3. And when I do, I get y is equal to -2 over 3x. And 6 divided by 3 is 2. Okay? So here we found our y-intercept form, which is fantastical. And we can start off at 2. We can go up 1, 2 over 1, 2, 3. It has a negative, so I know I want it to look like that. You want it going down, or I can go down 2 over 1, 2, 3. Now, let's say you have our standard form, which is 2x plus 3y is equal to 6. You can also create a table and find the two y-intercepts. So basically, you plug in 0 for x, you plug in 0 for y, and when you do that, you get, on the first one, 2 times 0 plus 3y is equal to 6. That's when I plug in x. So I end up with 3y is equal to 6. Divide each side by 3. I get y is equal to 2. Okay? I can erase all of that. Now I can plug in 0 for y. I get 2x plus 3 times 0 is equal to 6. And I end up with 2x is equal to 6. Divide each side by 2. X is equal to 3. So here's my other point, my other intercept. And I'm going to erase this again. So this is a more simplistic way of doing it. Now, depending on the problem, you might not be able to do it this way. So this right here is my y-intercept, and this is my x-intercept. Oh, wait a minute. Backwards. Okay, one more time. This is when x is 0, this is y, whatever y is. Oh, that I was right. I don't know why I'm being so silly. Y-intercept, and this is my x-intercept. Okay, so let's look at our graph. If we're looking for our y-intercept, look right here. Our y-intercept is 2. It's right here in the middle, right? And when we're looking at our x-intercept, it's right here at the 3.